We're at the high bay at Northrop Grumman, where we are about to get a bird's eye view of the Sunshield. To tell us more about the Sunshield, which is actually made up of 5 layers of a material called Kapton, we have Andy Tao. He's the chief engineer for the Sunshield. Andy, tell us first of all, what is the Sunshield for?
Well, the Sunshield's main purpose is to keep the energy from the sun from getting to the telescope. JWEST looks for very faint, basically thermal objects out in space. It's important to keep things really cold. So if we were to allow the telescope to heat up, the warmth of the telescope itself would just swamp out the sensors and it wouldn't be able to see anything except its own heat. The second thing is just to keep out the visible light also. The visible light can get inside the optical train and cause all kinds of interference, so we want to keep that out too.
Now, Andy, I mentioned before it has 5 layers of a material called Kapton. Before I ask you why 5, what's Kapton?
Kapton is essentially a space-age plastic film material. It's something that's been developed for a number of years, and we actually use it in our thermal insulation materials.
Okay, and 5 layers? Why is that?
5 layers, well, 6 would be too many and 4 would be too few.
You've got this down.
Yeah, well, it actually has to do with the amount of energy that we need to reject from the sun. The sun is putting in a certain amount of energy, and we need to reject that and make sure it doesn't get to the telescope. The Sunshield is built so that there's an angle between each one of the layers, so heat that comes off of layer 1 gets bounced out and actually gets rejected out the sides. So if the spacecraft was down here, we actually have a couple of holes in the Sunshield that allow heat to come up from the spacecraft and get pumped out through the sides. So the Sunshield is sort of like a giant heat pump, passive heat pump.
This is not the flight hardware, right? This is actually just a test article.
That's right. This is one of our series of development articles, and a very important one. It's full size, and it's pretty close to flight, but there's some important differences. All right, ready to come down? Coming down.
Oh boy.
These layers that you see right now actually will be coated with a vapor deposited aluminum.
Okay.
And that aluminum, which you see here on the underside of the thermal covers, is 99.99% reflective. So that helps a lot when we're trying to bounce all that thermal energy out of the Sunshield.
Okay.
Now the kind of pinkish purplish part is actually a silicon layer.
And that's the one that's exposed to the sun?
That's right. But we use the aluminum, the super highly reflected aluminum, everywhere else that we can to reject the heat.
Great. Thanks a lot. This silicon layer actually protects the Sunshield during launch. And when the James Webb Space Telescope Observatory reaches its destination 1 million miles from Earth, this silicone cover gets deployed. Thanks for joining us for another edition of Behind the Webb.